Okay, so this is a reminder of how to find all of the parts of a function from the graph. So we know that we're looking at a Ferris wheel and we're looking at when it starts, when it reaches its max. So we have our start, max, mid, min, and when it ends. So we know that we always start at time of 0. So the bottom of our scale here is time. So my starting point is at 0. So if I see my start right here, my starting height is 10. So if I start at 10, I remember on the Ferris wheel that I always start over here at the 3 o'clock position, which is the same thing as the height from the ground. So my starting number of 10 is my height from the ground, which happens to be this number at the end of our equation. So I have that started. And now I have to figure out how high does my Ferris wheel go if I start at 3 and I end up here at my maximum. So that's going to help me find my radius. So if I start at 10 and I work my way all the way up here to the maximum is 18. So that means that I had to go up 8 in order to get there. So I know that my radius is going to be 8. Finally, I need to figure out my angular speed. And in order to find angular speed, you can take how long one rotation or one period is and do 360 divided by one rotation. So I know that I have my 3 o'clock, I make it up to my 12 o'clock, I come back down here, I'm at 9 o'clock. At the very bottom of my Ferris wheel is 6 o'clock, and then I have to make my way back to middle. So this is back to center, and that's one rotation. So if one rotation takes me 6 seconds, that means that I have to do 360 degrees divided by 6 seconds, and I get 60 for my angular speed, which is degrees per second. And that's what goes in here. And then there's my equation. If I were to type that equation in Desmos, I would get this exact same exact same graph.